Okay, I'll start on number 25. 25 through 30 all have to do with distance problems. So what you want to remember on these is that distance equals rate times time. Now I do have my slate working, so hopefully my writing will be a little bit clearer on this. We will see. Okay, I'm going to change it to a clear fit pen. Okay, Crystal left the airport traveling toward the dump 4 hours before Mark. So here they are at the airport. Crystal's going to go this way towards the dump. Mark traveled in the opposite direction, going 15 miles per hour faster than Crystal for 2 hours, after which time they were 462 miles apart. So at some point in time, they're 462 miles apart. Mark's here, Crystal is here. So we need to talk about, this is the distance, so both of these will have their rate times the time. I do not know how fast Crystal was going. I do not know how fast Mark was going, but I know he was going 15 miles per hour faster than she was. So I'm going to say her rate is x, and his rate is going to be x plus 15. As far as time goes, he traveled for 2 hours, it says in the problem, and she traveled 4 hours before he did, so she would have traveled for 6 hours. So x times 6 is going to be 6x plus 2 times x plus 15 will equal their distance, which is 462 miles. Distribute 6x plus 2x plus 30 equals 462. So 8x equals, subtract 30, that'd be 432 divided by 8. 432 divided by 8 is 54. X is 54. So that means she was traveling 54 miles an hour, and that's what they asked, 54 miles per hour. If they had asked about him, it would be 15 miles faster than that, so he would have been at 69 miles per hour. And let's just double check it. If she traveled for 6 hours at 54 miles per hour, and he traveled for 2 at 69 miles per hour, would that give me 462 miles apart? And I just typed it in the calculator, and it is 462 miles. So you can double check your answer like that. All right, question 26. A cargo plane left New York and flew toward Moscow. A passenger plane left 1 hour later, flying at 200 miles per hour in an effort to catch up to the cargo plane. After flying for 4 hours, the passenger plane finally caught up. Find the cargo plane's average speed. So their distances will be equal when they catch up with each other. So rate times time equals rate times time. I'm going to have cargo and passenger plane. So I don't know what the time was, but if this plane, whoops, that wasn't lined up. If this cargo plane flew 2 hours, then the passenger plane would have flown 1 hour later, would be t minus 1. So t minus 1 on this side. I'm trying to get my pen in the right spot. That's way not in the right spot. T minus 1. As far as the rate, the passenger plane was flying at 200 miles per hour. And, oh, and they tell me that after 4 hours it caught up. Okay. So after flying for 4 hours, the passenger plane finally caught up. I'm making this harder than it has to be. How about this? If the passenger plane flew for 4 hours at 200 miles per hour, and the cargo plane would have left 1 hour before that, so it flew at 5 hours. How fast was it going so that they ended up at the same spot? So 5x equals 800 divided by 5. 800 divided by 5 is 160 miles per hour. So that cargo plane would have been going 160 miles per hour to catch up to that, for the passenger plane to catch up. All right, let's take a look at number 20. All right, problem 27. A passenger train left Seoul and traveled toward the fueling station at an average speed of 25 miles per hour. A cattle train left at the same time and traveled in the opposite direction with an average speed of 80 miles per hour. Find the number of hours the cattle train needs to travel before the trains are 1,155 miles apart. So it's kind of like the first one we did, where you got one going this way and one going this way. This is just so far off, it's driving me crazy. And we need them to be 1,155 miles apart. Or if I change my pen, if it would be better. Okay, so I've got a passenger train. Where is this at? Passenger train, and it is going to go towards the fueling station at an average of 25 miles per hour. So I'm just going to put 25 times x. I don't know how many hours it's going to go that way, 25 miles per hour. The cattle train is going to leave at the same time, so x is going to be my hours, but it's going to go 80 miles per hour. So 80 times x. So when will they be 1,155 miles per hour? So my equation is going to be 25x plus, sorry about that, 25x plus 80x equals 1155. Combine that, that's 105x equals 1155. Divide by 105, and you get that x is 11. So after 11 hours, see, after 11 hours, the 11 times 25, after 11 hours, this passenger train would have gone 275 miles. I don't know what's up with this pen. 275 miles. And then after 11 hours, the cattle train, 80 times 11 is 880 miles. And 275 plus 880 is 1155. All right. Okay, here we have a diesel train that's leaving and traveling towards New York at an average speed of 56 kilometers per hour. So it's going to 56 kilometers per hour. I don't know how many hours. And a cattle train left sometime later going in the same direction at 70 miles per hour. I don't know how long. After traveling for 4 hours, the cattle train caught up with the diesel train. So however many hours this one had been traveling, this one was traveling 4 hours less. And they're at the same spot. So they want us to find how long had the diesel train traveled before the cattle train caught up. So when will 56x equal 70 times x minus 4? So you just want to distribute. Subtract 70 minus 56 would be negative 14x. Negative 14x equals negative 280. Divide negative 280 by negative 14, and I get x equals 20. So after 20 hours, the diesel train would have caught up with the cattle train. I said that backwards. After 20 hours, the cattle train would have caught up with the diesel train that was traveling slower than it was. So if you'll look after 20 hours how far this one had gone, and then do this one, it'd be after 16 hours because it left 4 hours later, and you'll get the same amount of the same distance. All right, problem 29. A container ship left the Azores and traveled toward Tahiti at an average speed of 20 miles per hour. A cruise ship left 6 hours later and traveled in the opposite direction with an average speed of 20 miles per hour. Find the number of hours the cruise ship needs to travel before these ships are 400 miles apart. So I need them to be 400 miles apart. So this is going to be the container ship over here, and this is going to be the cruise ship over here. So the container ship is going to travel an average speed of 20 miles per hour. So 20x. The cruise ship is going to leave 6 hours later, and it's still going to go 20 miles per hour. So it's going to be 20, but instead of it being x, it's going to be x minus 6 because it's traveling for 6 hours less. So my equation is 20x plus 20 times x minus 6 equals 400. And you just want to distribute. Add 120. 400 plus 120 is 520. So I get 40x equals 520. Divide by 40, and you get x equals 13. X equals 13. So the cruise ship, listen, that's how long the container ship would travel. It's 13 hours. The cruise ship left 6 hours after that. So if x is 13, the cruise ship traveled for 7 hours. 13 minus 6. So my answer to this question is 7 hours. A cattle trip made a trip to New York and back. The trip there took 3 hours, and the trip back was 5 hours. It averaged 36 miles per hour faster on the trip there than on the return trip. So I'm going to call this x plus 36, and this one I'm just going to call x because it was 36 miles per hour faster this time than it was this time. So I want them to be equal distances because whether you're going to New York or back, it's the same distance. So 3x plus 108 equals 5x. So 108 equals 2x. Divide by 2, you get 54 equals x. X is 54, so coming back, they drove 54 miles per hour. Going there, it went 54 plus 36, which is 90 miles per hour. And they want to know on the outbound, that's when you're going out. So the outbound would be 90 miles per hour. Hopefully that helps you. If you got any more questions on 25 through 30, let me know.